right, finally we got a, well, partially insulated glass specialist, but in an area that seems very overlooked. We're going to focus now on the edge, which is a huge contributor to performance, but something that people don't pay a lot of attention to. So let me back up for a second and introduce yourself to our audience.
Yeah, sure. So I'm Brian White. I'm the technical director at H.B. Fuller Company for our Building Adhesive Solutions Group. I've been working in the fenestration industry for about 15 years now. Started formulating sealants in the lab, and here we are now. So been a part of the industry for quite a while, and it's been quite a trip.
So Brian, when it comes to like assessing whole window performance, so often we try to optimize the frame. You have a few suppliers here that are alternate framing systems to aluminum. So you have various UPVC options or fiberglass options, aluminum options in the market to consider for enhanced thermal performance. Then everybody focuses on the center of glass for performance. But do you think, I guess this is a very vague question, but do you think when we're modeling whole window performance accurately, do you think certain factors are overlooked when it comes to edge of glass performance? And how can we do a better job of educating the market on the implications of selecting the right spacer system?
Yeah, I think the modeling is done pretty well, and I don't think there's necessarily anything overlooked in the particular model. But that being said, the model is really a snapshot in time, and that's kind of at the, you're looking at that model is calculated at the best case scenario. That unit is made perfectly. It's got exactly the gas fill that they model. All that performance is dependent really on kind of that one snapshot in time. And when looking at IG performance over the decades that we hope that it's in the facade or in the building, you really need to take into account the longevity of that seal as well. So modeling a particular U factor when the argon is at 95% or whatever, isn't necessarily going to indicate that unit's going to perform the same way, a decade down the road if some of the argon's leaked out. So it's really important, I think. I don't know how you can address it on the modeling side of it, but just understanding the performance of that edge seal and how it deals with the day-to-day weathering that units go through, I think is really important. And longevity is going to drive sort of that long-term, energy savings and performance that we all kind of want out of a high-performance facade.
So have you seen or witnessed in person, maybe not, any type of like as-built thermal imaging or reading to understand either post-new construction, especially in some of these jurisdictions where we have various means of like accounting measures in terms of how the facade is performing relative to the benchmark or the baseline for what was designed, then as installed, then 5 years down the line. So seeing that degradation, as you described, does it ultimately come down to, are you losing that argon fill? Are you starting to get vapor entering into the airspace? It doesn't have to be this catastrophic event of like, okay, IGU failed, now we have, fog within the IGU. It's a process over time, right?
Right, yeah, absolutely. I have yet to see really good studies looking at, really good controlled studies that say, okay, what was this unit day one? What is it now? There hasn't been a lot of that executed yet, but we do see that starting to build that momentum. So I know organizations like NFRC are starting to look at, okay, how do we look at, the unit's retention of performance over time? There's groups in Europe that are starting to look at this. So I do know it's a question that's bubbling up, I think, from the industry, but not something that I'm aware of not something that has been studied all that well yet that I'm aware of.
And do you start to risk this performance when your standard IGU fabricator is going to say 50 square feet is your magic number where you can have your 1 inch, 6 millimeter makeup under relatively moderate design pressures and not run into deflection issues. Then when you start going into larger spans, maybe you need a thicker light and so forth. But when you get into these atypical makeups, really huge sizes under your higher wind loads or design pressures, how much stress is that putting on the actual edge in the spacer system?
Oh, that's a great question. I guess from a definite number, I'm not completely sure off the top of my head.
Relatively, yeah. What's going on there?
Yeah. The stress being applied to that edge seal in a unit, let's just say a 50 square foot unit or something like that, is really going to be a mixture of the extent to which the glass is deflecting and putting kind of a tensile type force on there, almost a cleavage type force, depending on kind of how the glass is sort of working around the edge seal. But then it's also seeing compressive forces. So compressive forces, I would say, due to wind loads, but then also tensile forces due to the expansion of the glass just during daily cycling and things like that, or daily temperature cycling, things like that. So, yeah, that edge seal is seeing a lot of different forces, right? So, all the more reason to make sure that it's high quality, bonded well, made well, that kind of thing.
do you see bigger issues today? I think there's more education around it, but is the bigger issue the design of the edge seal or the actual execution in the plant?
I'd say the execution is typically the real big factor in the longevity of the unit, right? I mean, there's a lot of well understood and well known ways to put IG together, and pretty well described. You know, whether it's a box space unit with a couple millimeters of polyester-butylene, or whether it's a reactive TPS unit, you know, that kind of thing. They're all pretty well described, but yeah, the actual execution and quality control is a huge component of longevity in the field.
And have you seen any of these sort of theoretical concepts about, you know, the concept of the forever IGU, being able to maintain an IGU in place and be able to, you know, recreate that hermetic seal or refill it with argon or krypton or whatever is filling that cavity? Do you think this is a sort of like a scientific approach that's continuing to be studied or looked at, or do you think we've kind of accepted, here's your predominant limitations in terms of IGU lifespan, your 20, 30 years roughly, and now how can we just optimize those 20 to 30 years and then create ease of replacement so that we can replace those units over time?
Yeah, I think when you're looking at a IG unit sealed with polymeric compounds, you're never going to get 100%, you know, hermetic seal. Everything has a permeability to moisture, that kind of thing. So it's something that's never going to be 100%, you know, like a forever unit, right? That being said, I think, you know, there's pretty good advances in terms of, you know, minimizing that moisture transmission as best we can, and increasing desiccant content, and really driving and working with the edge seal to mitigate, you know, the forces it sees to prevent seal failure, that kind of thing. So I think, you know, we're extending the lifespan of the units in fairly large increments, I think, based on technology as we move forward. So I think just by continuing down that path, I think trying to, you know, get those moisture vapor transmission rates as low as possible, getting enough desiccant in there, because if you have a stable seal, the desiccant and the MVTR would drive the service life of the unit. So I mean, it's entirely possible to see units that are going to be, you know, 30, 40, 50, 60 years in the field, again, depending on their environment. But I think, you know, but working on those high performance edge seals, and then tying that into ease of replacement, things like that, I think are going to drive. Okay. So, well, I think we'll see that going forward, I think, a little bit.
More informed decisions. To wrap up, Brian, where are some places people can go to learn more about what H.B. Fuller is developing and implementing in the market?
Yeah, you could go to our website, www.hbfuller.com. We're present at a lot of, specifically if you're in the building industry, we're at a lot of the different industry events like FGIA and Glass Build and all those kind of things. And so if you see our booth or you see any of us walking around or head to our website or whatever, feel free to reach out. We like to talk glass.
Awesome. Thanks for coming on.
Thank you.
Oh, man. Welcome to Seattle for the next live edition of the podcast. And we have a repeat podcast host, Spencer, here all the way 3,000 miles away from home base. So, Spencer, thanks for coming back on.
Thank you. It's good to be here.
So I actually thought an interesting topic to talk about with you would be the sustainability realm of things, and when the design community is looking for sustainable paths when it comes to material selection, material procurement, and trying to follow guidelines like LEED. I don't even know if there really are like paths to comply from a code standpoint, but I think this is a topic that's a little bit conflated, and there's a lot of mixed messaging around, especially with your experience. This is why I wanted to touch on it with you, is from the aluminum sourcing world, especially in your Schuco days, how you would classify things like the recyclability, and what was the term that was common to use, like end-to-end sourcing, or
like life cycle analysis?
Yeah.
Kind of common.
So just talking about like material selection, especially selecting your facade assemblies and systems, how architects can sort of think about this from a different perspective in terms of like what are the big driving factors that really move the needle versus what's probably not getting you very far.
I think what's important anytime we discuss sustainability in facades, you have to frame it categorically in what your targets are, right? Obviously, we could go into the energy, conservation and performance of the assemblies, talking about thermal efficiencies and whatnot. But on a material selection basis, I think you have kind of an emerging focus in the industry right now that's really exciting around like the carbon footprint of the material. And with aluminum, this is especially sensitive because aluminum is so energy intensive to produce and then also to process. And in our industry, working with extruded aluminum, it's incredibly energy intensive. And, relative to other materials that could be used as a facade, enclosure, it's on the higher end of the spectrum. Really, the only way to address this fundamentally is to look at the point source energy for your material supply chain. And that's pretty limited depending on where the material is coming from. In the past, working with European extruders, there's really big initiatives to track and quantify that supply chain so that you can essentially buy an aluminum extrusion from a facade manufacturer or wholesale distribution company, and then they provide verification and a certificate that says, here's where this was extruded, here's the point source energy used. We can verify that that energy source was from a certain percentage of kind of renewable energy generation, or here's the carbon footprint that comes out of that if it was a non-renewable source. And that's something that is really, I think, emerging in the industry here in the United States. It's pretty exciting, but it's also a bit daunting. I'm certainly not an expert in the topic. There's other people in the industry who are doing a lot of good work in this direction. But it is part of the sustainability discussion now that we're having, like a more contemporary discussion.
Well, yeah, I'm sure this is something that was brought up when you were in school in Europe. And like you just said, it's the sourcing of the material, and then, how well performing can you get the assembly to be to lower your operational carbon, but also the energy source as well, where you're sourcing your energy from in the grid. And it's like all these factors when it comes to durability, maintainability, life cycle of the facade. There's this constant push and pull.
Yeah.
And I feel like you're always going to have to compromise in one area to benefit in another.
It's interesting that, we talk about the life cycle of a building, right? And the building enclosure is kind of paramount in that discussion, because the performance of your facade in a lot of ways defines like how relevant the building is to like contemporary requirements, whether it's user comfort or code compliance or energy efficiency. And what's really, I think, a low-hanging fruit for the facade industry, separate from evaluating the material supply chain, which is really important, is looking at this concept of adaptability, right? And kind of future-proofing the building through intelligent design. And this is something that is really, in a lot of ways, dependent on the client and the project, what their time horizon is for, usage and, ownership of the building. But I think it's something that, when I say is low-hanging fruit, it can be solved through intelligent system design, right? It's very easy to approach the topic of adaptability and future-proofing if you get into, the design of the project and assign that as like a tenet of the outcome that you're trying to achieve. If it's an actual goal that you're going to say, okay, I want to have this facade where we can replace the glass easily in the future to accommodate a higher performing product, or we have the ability to disassemble the facade entirely with minimal, destruction to material, minimal waste generation, right? With the goal of then improving the performance of the facade in the future through additional insulation or, remediation efforts that maybe, improve the overall performance in terms of like water infiltration resistance. These are things that in a lot of ways are kind of counter to, I think, some of the priorities that we have on like a product design basis generally in the industry, right? Normally we're very focused on maintaining low costs for like upfront costs, and also simplifying the installation. And what you find when you get into the design of adaptability, installation methods may not be as easy than if you just had like a more, like permanent solution, in the sense that it's something you put on the building once and then it's very hard to disassemble without demolishing, the facade. But there are definitely means and methods to achieve this. And I think that, there isn't necessarily, as far as I know, like a core metric industry-wide that's like a code compliance item around adaptability. It's more about like architects and consultants specifying this as like a criteria on top of whatever would be in place for code compliance or some other sustainability target that maybe has a better defined use case.
And do you think it's interesting? I was actually with an architect in the Midwest in more of a heating dominated climate yesterday or 2 days ago, and there was a lot of pushback around triple glazing, just around the thought of the cost increase. And I was like, I don't push that aside. They were trying to comply with LEED. And I think there was this thought process or initiative that getting additional LEED points meant a more sustainable building and a better outcome. And I think there's been some discussion on this topic and disagreement around the effectiveness of some of that. And, I think there the design community is trying to make more informed decisions, but I think the decision-making framework is somewhat limited in terms of maybe a little bit of knowledge sharing and understanding what's out there, but also understanding where they can really move the needle and what they're ultimately really trying to achieve.
Yeah, I mean, I think LEED, it's something that I think has faced a lot of criticism, since its inception around like what's an effective implementation of sustainability, in architecture, right? And we can debate that kind of ad nauseum, like where the real priority is, coming at it from the climate change perspective. Obviously, energy efficiency is like paramount above like bike racks, right? But bike racks are still really important, and I think that maybe one high level way to look at this is that LEED has definitely provided a vehicle to bring multiple topics that you could define as, related to sustainability into the discourse, and also provide a framework to like really implement them and track them, which I think is super important, and there are other standards that are kind of coming online as, additional possible like compliance paths to achieving like energy, performance goals, or, even now with, California looking at implementing like, carbon footprint tracking on certain materials in the buildings based on their code requirements. It evolves slowly. I think that, LEED still definitely has like, it's kind of like a cornerstone to the industry when we talk about sustainability, right? It's not the end all be all. It's not where we're going to land eventually, but it's definitely like foundational to implementing a lot of these strategies. And, I think it's been pretty effective in that way. And the criteria is evolving. This is the most important thing, right? It's not static criteria. So, as we move into these other focuses of sustainability, I think it's not like too far-fetched to think that like LEED will eventually incorporate a lot of these topics as we go further.
Given your sort of experience or expertise in unitized curtain wall to sort of round this out, what is one change moving forward you'd really like to see more of in terms of newer designs? I see some like double skin facades or ventilated facades coming out on the market, stuff that we would have seen as somewhat commonplace in Europe. What's one thing that you wish you'd see more of here domestically in the unitized world?
Yeah, I think fundamentally it's this idea of future-proofing through like ability to disassemble facades without demolition. I think that's really important because there's always a requirement generally in especially unitized facades, with a lot of glazing, that you have ease of glass replacement, right? And that's one piece of this. And it's probably in a lot of cases the biggest piece, right? Because we get improvements in the glass packages through, improved material science and product developments in that industry, which we can then directly apply to what we're doing. And, IGUs have a shelf life, right? Like they don't last forever, right? They have a point of kind of diminishing performance. So they need to be replaceable in the future. But I think if we look beyond that, there's definitely like a greater life cycle analysis that you can evaluate a facade from. That's not just about the degradation of the IGU, but it's more about, the perimeter sealants, the framing system itself, right? Which, for the viability of an extruded piece of aluminum is quite long relative to the operational use of a building. But having the ability to disassemble a facade and upgrade opaque areas of the building, I think is critical, as we get to a point where, codes are getting more and more aggressive. And as we look at kind of holistically improving the performance of buildings, the facade is the low-hanging fruit to do that. And if you have the ability to go back to an existing building, upgrade it, from the perspective of energy efficiency, you're now improving the life cycle, equation for that building, right? And you're minimizing the waste. And I think that's really critical. You look at a lot of these projects that we're doing in big cities, which are office to residential conversion. That is such a great opportunity in that moment where you're going to be, demoing a lot of the existing facade. Look to the future of what is this actually going to be able to do 20 years, 30 years out? And how are you going to have to come back and address that, when the codes change or when you want to improve the efficiency even more than what's required today? So, like I said, it's in my mind, there's definitely added complexity on a system design level, but I think it's something that we can start doing right away, like as an industry. It's really just a hot take, though.
So maintainability of curtain walls, not just focusing on the vision area, but also spandrel area. Great takeaway. Thanks for coming on, Spencer.
Yeah, thank you.
All right, Irene, thank you for coming on. That last panel was great.
Thank you very much, Adrian. Thank you for having me. Nice to meet you.
Of course. And you made an interesting comment about kind of making more informed decisions with our energy modeling decisions and how we're making design decisions today for the future. And you actually made the comment about weather, which is something I hadn't put a lot of thought into, which maybe it's something we need to be putting more thought into. So there had to be some aha moment or wake up call for you where you're like, this is not accurate.
Actually, this has been a topic that I've been bringing up fairly regularly with clients. It's something that back in 2006 to 2011, I actually worked from our London office. And for part of that time, I was in the environmental physics team where we had people who were, amazing physicists and scientists working with academia to develop future, basically morphed weather data files. Mm-hmm. So I've been aware of this kind of capability for quite some time now. And it's been developed into WeatherShift, which is something that Arup has offered. And, every weather file, it doesn't even cost that much to purchase these morphed weather data files, but it just makes our building designs that much more accurate. When I started at Arup, one of my first projects was energy modeling for an existing building. So I basically had to try to calibrate the energy model to existing utility data, which was very fascinating. And I just know that if we don't use accurate weather data, that, when we're designing a new building, it's going to be occupied in the future, not in the past.
Sure, yeah.
So designing with historical weather data doesn't actually make sense. You're starting off with the wrong assumptions to begin with.
So because you're in LA in such a moderate climate zone, instead of extremes like the Northeast or in a hurricane zone or even here in the Pacific Northwest, are your projects really widespread? There's a lot of supply in California.
Yes. So actually, our team covers what we call the America's West geography. So we do a lot of projects in the Pacific Northwest. We do a lot of projects in California, but we also work with clients who have international projects. So every time we start on a new project, it's fun for me to just look at the climate data, look at what the trends are, like, is this a heating dominated building? Is this a cooling dominated building? What is the building typology? What are the primary design drivers that we can help control or optimize?
And what are the big variables that really move the needle? Are we talking about like solar patterns, like warmer summers, colder winters? What's really driving design decisions?
Solar patterns, I think, are not shifting as much. It's usually warmer, hotter summers. It depends on the specific location as well. Sometimes it's colder, wetter winters. Sometimes it's a bit of both. But overall, there's actually much more humidity in the air. And so we're seeing much more extreme storm systems. Water is a great moderator of temperature. And so actually a lot of the global warming has been absorbed in our ocean. So ocean, water temperatures have actually increased a lot more than ambient air temperatures. And so I think just that it's not just temperature, but it's also enthalpy, right? It's like that different balance in the water cycle. My background is actually in environmental engineering in California, where I studied water in my undergrad and grad school, and I just happened to kind of like fall into energy efficient buildings.
Yeah, this is not something, and might sound misinformed by asking the wrong questions, but if you think about, like you just said, more moist air or like wind-driven rain, if storms are getting more extreme, how do design pressures and wind loads factor into this, and understanding how the facade is going to behave under those extreme conditions and keeping the envelope weather tight?
I think we already saw some of that with Superstorm Sandy, where I don't think New York was necessarily expecting such extreme storms, but the hazard maps are actually shifting, and we also need to, not only do we need to be modeling our energy use, thermal comfort with future morphed weather data, we also need to be tracking what the hazard maps look like, just like what does the hurricane risk look like.
So I'm gonna throw a wild question out there that I haven't asked before, but we keep energy codes become more and more stringent. Maybe British Columbia is the most extreme. I'm in the Northeast, so I'm accustomed to Boston, which is very extreme. Then you really ratchet down from New York to DC, but the U value targets keep getting more stringent. And in Boston, on this podcast, I asked why the air infiltration requirements aren't becoming more stringent, but it's all revolved around energy. But why aren't we looking at it from the standpoint of design pressures and wind loads and the design pressures that the cladding is designed to withstand?
Well, we do need to look at all of that in conjunction, and that's why during the panel I mentioned, reaching across disciplines, really designing our facades holistically, because if we have a building that is energy efficient and comfortable, but it's not safe, then I don't think people will want to work in this building or live in this building, right? So, so it's really important to understand that there are many parameters, some of which have higher priorities than others. We just need to find that right balance. There are certainly trade-offs, but having that open dialogue with the owner, with the entire design team, understanding where we can compromise and where we need to kind of hold the line is really important. I've been working on a project recently where, because of cost reasons, the client doesn't want to use laminated glazing for safety purposes, but fall protection, just fully tempered, and obviously we would specify heat soak tested, but we were really pushing for laminated glass because it can serve the dual function of safety glazing and fall protection because it's a high-rise building.
I was going to say you probably exist for the most part at the apex of the performance spectrum or realm in terms of project typology, but I'm guessing the answer is no. You're probably dealing with a vast spectrum or range of projects that are design-driven, cost-driven, performance-driven, and how do we find
Absolutely. It really does depend on who our clients are. As of last year, I've been sitting on the IECC subcommittee for commercial envelopes and embodied energy. And it's funny because when we sit in on those meetings, we do have to realize that, yes, at Arup, we work on mostly high performance buildings, but those codes are designed for all buildings. And so probably roughly 90% of all buildings just follow the prescriptive code. And so we have to make sure that we accommodate for all types of buildings, different levels of sophistication, but we still need to design them in a way that meets code, whether it's safety related, energy related, but also make them high performing in terms of the user experience in as much as we can.
Well, look at the comment earlier about how if we're achieving baseline code minimums, at some point there's a diminishing return in terms of finding that balance between operational and embodied. Maybe local codes here are doing that effectively. And part of what I've been trying to figure out is these stretch codes that come into market and everyone's like, what are we going to do? And they're all scrambling. Do you think it has been effective here?
I actually personally love working on Seattle-based projects just because the code is much more forward-thinking than some other jurisdictions that I've worked in, and so it's always more fun to work on those projects where there's really more kind of building physics meat to sink my teeth into, so to speak. I know that sounds
I get it.
It makes me sound very geeky, but the only complaint that I have is that codes have pushed so much for highly insulative envelopes that sometimes there's the unintended consequence of increasing condensation risk, because a lot of the projects that I work on are curtain wall projects where we can't apply the insulation to the exterior. When we're working in a cold climate where we want where the vapor drive is from the interior to the exterior, so we want the insulation to be on the exterior of the structure or the framing. So we're limited to putting insulation on the interior, and that ends up drawing the dew point line inboard, which leads to potentially increased interstitial condensation risk.
And how do you deal with that, especially in an existing building retrofit where you might be limited to interior space and have to find that balance?
Yeah, that's a great question. We haven't done too many retrofits as of now. A lot of, I guess the retrofits that we have worked on are California-based, where U factors are not as important as solar heat gain coefficients. And so in some ways we can get away with not highly insulating our buildings, but where we do need to make those considerations, we have to just ensure that the layering of the facade is appropriate, that we don't inadvertently design a double vapor control layer that can trap any interstitial moisture, that there's always one side of the assembly that it can permeate through. So selecting the right material.
And another theme is thinking about maintainability over time or adaptability, and especially when you see office to residential conversions or vice versa, in a residential type application where you have all the steam, you're cooking pasta or showering, and how are you designing the envelope and insulating in that aspect versus office where you don't deal with that at all. So that challenge of thinking through, well, are we going to need a different use for this, whether it's a hotel or what in the future, and thinking through those scenarios.
Yeah, that's a great point. I think designing for future flexibility is definitely something that we should aspire to. It's not often easy to predict what those future modifications are to a building that you're trying to design very specifically for, but that's definitely something to aspire to.
So on a closing note, because you get to work on projects globally or predominantly in the Western region, what project did you really get to sink your teeth into and you'd say you either feel like you had the biggest impact on or you're most proud of?
That's a great question. I think one of my favorite projects is actually the Amon Carter Museum in Fort Worth, Texas. I have a soft spot for existing museum buildings that need to be retrofitted. It had this east-facing main, glazed main entrance that was just being blasted by solar radiation, and obviously it's a museum, so the artwork needed to be protected. And so I got the chance to work very closely with our lighting consultant, where he, looked at mitigating light levels and UV levels, while I focused more on the thermal and solar performance, and just going on site, taking measurements. The existing frame was actually this was a building from the 1960s, but it was retrofitted in the early 90s, but the frame still wasn't thermally broken. And so with the amount of solar radiation hitting the frame, it was actually expanding and contracting so much that you could see like metal shavings on the framing. And the glass was also pillowing very significantly. So being able to work very closely with my supervisor at the time, Matt Williams. I don't know if you know Matt, but I have to give him a shout out for all the detailing. And then we had our structural engineer, Troy Zazula at the time, who did all the structural glass calcs for deflection limits and redesigning the facade so that it wasn't pillowing, it was thermally broken, so there wasn't condensation risk. It was just a fun puzzle to solve because it had so many things that were wrong with it that we could then go in and fix.
What I'm taking from your experience is what makes a really good consultant is being able to wear the specific hat to the specific geography or climate zone, and whether it's Seattle to Fort Worth, Texas, very different requirements, different clientele, and applying first principles and building physics and trying to make the informed decisions based on that.
Absolutely.
So
it depends is the answer.
Yes. So thanks for coming on. Really nice.
Thank you for having me. Yeah, very nice to meet you too.
Here we go. We got another actual repeat guest. Wow, I am fortunate enough to fly all the way to Seattle and run into one of my fan favorites. So welcome on, Brad. I think on this segment, what I want to focus on with you, especially understanding the glazing world from a contracting and design side, but mainly from a product side, how do people measure the true value of a product? And especially leaving that last segment, what are some initial thoughts?
It was interesting. So the last segment, they're going to catch everybody about, it was really kind of understanding from an architect's perspective, some past projects that they've actually looked at from a living building challenge measurement tool. They have different things inside of that that allow for different incentives to play out for municipalities and also to offer back for developers, right? So that is a marketing tool, but it also translates into really healthy buildings, right? So now as you're translating that tool into saying to it, how do you measure that value of the product according to the project that you need to deliver? Because I think the argument is that if we're just going to be this, we're always going to be just doing the minimum. I think it's a training program for products only to just respond to the minimum level in order for us to just get the job or just get there from a value. So I don't think we're actually like asking that question is like, what's the true value of that product? And how does that translate into those projects, right? I think that's the direction of it. So,
And interestingly, now that I think about it, are manufacturers incentivized to go above and beyond, as you said in the past, from a research and development standpoint, to think about not only where do we need to be this year or in 3 years from right now, but positioning products to go above and beyond. If you're too expensive or if your performance is
yeah,
too far above code, like a
Yeah,
certain
you-
product we were talking about before,
yes.
the market might just not be ready for it.
Well, and I think you get really romantic about what that performance is going to be. And if you become romantic about it, you're like, it's like all of a sudden everybody likes their own brand, and it can come across communicatively to a market that just wants to be there enough to meet their project requirements. It can come across as a place of like, I'm just too expensive for this type of a thing, or I am also a lot to deal with. So high maintenance kind of comes out of it type of a thing. Because if you come across as like, well, there's all of these things checked, and you're like, oh, wait a minute, maybe I'm just asking the wrong person or wrong product the wrong question. So they move on to a different product. So I don't know. I think there's two arguments that you have on that side of it, and innovation needs to be a portion of the business that actually challenges you as a product or a manufacturer to continue to respond to the market demands that are forthcoming. So I do think manufacturers have a little bit of that foresight, but they also have that beast that they need to feed in order to make sure that they're going to. So now they look at throughput, they look at how Six Sigma is going to be a part of that, and they actually see that, okay, that can increase not only just reliability, safety, but also a profitability standpoint for them. They have a place where you need to be accessible from an invitation standpoint, and actually make sure that you actually do have a place that you're translating into these programs to get you to certain levels and kind of help navigate like an empathetic role for these architects, an empathetic role being like, hey, we are Building Challenge certified up to these levels. If you would like to do that, here's the resource team that can help you, rather than be like, well, we have great energy values. How do I navigate that through a Living Building Challenge? How do I navigate that through a LEED Platinum certification? I think there has to be both ways of saying, yeah, I'm really innovative and I can actually meet this level, but I do think that you actually make sure that you have to be accessible for you're going to allow you allow the developer or architect to drive that bus.
Yeah, and
what's your thoughts there? I don't know.
Well, there's a certain fenestration supplier that we both know well that really sold themselves off. It's comparing fenestration to like automobiles. You
Sure.
think about like, what are you truly getting? And they're selling this brand and like exclusivity.
Yeah.
And for a little while, there were certain fenestration suppliers that could achieve performance values that others can't.
Right.
Now that a lot of that's sort of been leveled out,
Oh man.
it's tough. All of a sudden, are you just selling a premium name? And then do people expose you when they're really not getting 20% more value?
Well,
What is value when it comes, you really look at a product standpoint, how these companies differentiate themselves.
Well, and I think there's that accessibility is a big part of that, of how to do it. I think we live in such an on-demand world of like, hey, like just if you're going to watch, why would I actually want to listen to a podcast on Tuesday nights when it's only live on Tuesday nights? I want to be able to actually go to All Things Facades and listen to it anytime that I want. So there's an accessibility to that. There's a place where that's in my culture of how I actually, I don't know, work every single day. Like, I know that I have to go shopping for a new shirt or something like that. But the only thing that is going to occur to me at 9:45 p.m. when I actually just want to pull up Amazon or pull up a couple places and actually go shopping. So that experience has changed. So your accessibility has to be that for a product as well. So think about that in a way that allows the user of your product to actually be accessible in those places. Now you have to then navigate how I'm going to get to what this user wants. So you have to have that marketing place and that campaign or that communication that's going to come saying that we actually here's our LEED certified products or projects, here's our Living Building Challenge projects that we've been on, and you have to show that to a place of where you're going to be at, because I think those are the benchmarks that developers and architects are currently after that need to actually have that. And I think product manufacturers go from the opposite way of saying that, man, it's 4 7/8 deep. I've got actually a U value of X that's going to be this way, and it doesn't necessarily translate to what that user demand is going to be.
Well, somebody that was just in here that we were talking to, he, in his past life, I mean, he's talked through with me before, they were high-end supplier in the commercial fenestration world, and he would hold hands with architects detailing and running structural models and running thermal models every step along the way, kind of like in a free-con capacity to give them that higher level. And then you could charge a premium for that service offering. But how scalable is that? If you're an architect, what do you want? If it's a productized solution, plug and play accessibility, you want that ease of use. If you're going to pay for a higher premium brand, you probably want that hand holding along the way to get you to where you need to go.
I think in this market today, you not only want the hand holding along the way, but you want also what premium actually means is someone that's going to also not just like you're maybe not going to pay 20% more, but you are going to be there to service the job into a place of saying that where's the transparency to make sure that that budget is maintained, not only performance is maintained, rather than saying that, oh, I've got project or product X that's going to come in and be 20% underneath you. Maybe you did all the legwork to actually do it. Now they actually have the answers to the test and they can just respond. I think that premium value from that architect is going to be like, they'll offer like a place of like, no, this guy helped me out. There's a place of like, let's make sure that he meets a market demand that's there. I think you as that product has to actually meet the market demand, not only from a performance standpoint, but also from that budget expectation.
And we've had this discussion before, but now that you have such vast competition coming in from all over the world, is that we talk about that 20% premium.
Sure.
Is that floor just dropping lower and lower?
From a product standpoint, I think that the floor is going to be your performance. That's the exchange that you're going to get when you actually do have a budget level that consistently drops. Because at the end of the day, it's either you're going to give up performance or you're going to give up scope in order to get a budget direction you want to be.
What's the performance stressor right now? It's thermal, because
it is.
Still see commercial grade windows going on. They only need to pass a 6 PSF test in the field.
Right.
It's not like we're watching punched operable windows have to achieve 20, 25 PSF in the field. So that's not going up. It's really just how do we improve the thermal values? How do we drive down costs? So the frame has to get better. The glass infill has to get better. And at some point, as you said, it's like, this is our baseline criteria we need to achieve from a certain owner or construction manager standpoint. What's the cheapest path to get there?
Well, I think that's the reason why you have those when architects actually design to those levels of a living building challenge or LEED Platinum, or the direction of if it's going to be a whole energy building model that's come to it. I think that actually raises the demand of not only the performance of a U value, it raises the demand of the performance of the team that needs to support that. So that's what I mean by performance. Is going to be a lot of the controlling of the floor, because sure, I think you can always go out and find something that's going to be the same overall air, water, structural performance, but not have anywhere near the team availability to execute that type of a thing.
So on a last note, from your perspective, who's the bulk of that responsibility on? And maybe it's a combination of both, the manufacturer or the glazing subcontractor. That support you're describing.
I think that the manufacturer's product will remain. So then if I go back to a project that I looked at that I was involved with, that yes, I was the team that did it, a part of it, but that product that's going to remain there is kind of like that's really going to have to stand the test of time. So I think it's a challenge to the manufacturers that you're going to be there, like, and you actually own that for the next life cycle of that project. So I think the challenge is more on the manufacturing side of things now, but I will append that with the marriage of just saying that I believe that the team that actually executes that is how well the glazing subcontractor is partnered with that manufacturer. I think that there's an enormous amount of distrust that would happen from glazing subcontractor to manufacturer, because every manufacturer can meet that said performance, right? So there leaves that type of a thing. I think there needs to be the challenge of the glazing subcontractor to bring that manufacturer into that team and to see if they actually work well with the team that's going to execute. And I say bring it even like have the glazing subcontractor invite that manufacturer up to the GC level, invite it to the owner level, to the consultant level, and just see where they respond to. Because you could be an awesome, like you're Clydesdale of a product, right? That's awesome. Like, yep, it's going to be great. But if they actually get introduced to this process of team execution, that's, I think, where the fine line kind of goes into. But I do think it's a challenge on both sides of making sure that the manufacturer is going to be there for a long time, but you're going to actually have the glazing subcontractor challenge a manufacturer a little bit with not only just price, or not only just like you have a product, how well you're going to work with the team. So, and I did a think on there.
Solid answer.
Thanks, bro.
for coming on.
I appreciate it.
Wow, Richard, you finally made it on. And I better make sure we get this. We are ultimately here to promote Structural Glass Design Manual. So, Richard, welcome.
Thank you. Good to talk to you.
Thanks for coming on. So, tell us how it's been.
It's been a while in the coming. We started off with a project 15 years ago. The building department didn't know how to deal with it. It was nicely designed, but they were saying, where's the standard? What do we do it to? And the answer is there wasn't really anything out there. And the more we went into it, we realized that this was actually an impediment to getting glass built and great glass jobs getting done in the United States. So, part of the challenge of writing a standard is that glass is okay in some circumstances and not in others. So the thing that people can relate to is, if you've got a window and it gets hit by a baseball, generally doesn't matter. You get a window in Florida and gets hit by a 2x4, it can blow the entire place up in a hurricane situation. So that's just sort of an example of, we think of glass being important in some circumstances, and it's covered for things like glass floors, it's covered for certain other structural applications, but there's this whole spectrum of projects which are not yet covered. And so this isn't trying to be a prescriptive approach, this is trying to be like, how do we get to the point where architects are comfortable with it, the guys bidding it know what they're bidding on and what they're expected to do, so that when it gets pushed over the fence, they've got a way of understanding what it is. And owners, what are they buying? Okay, are they getting what they're paid for? And building departments, how many times do you go, I want to do this glass wall. Do you think you can get it through the building department? Not sure. Oh, maybe we should do something else. Because uncertainty kills things. So giving people a way of saying, this is a design philosophy that makes sense for glass in this circumstance and that glass in this circumstance. And that's something which is unique to glass, and I think this book handles it better than any of the other glass standards and design manuals out there.
What is your goal? And I'm guessing the answer is no. I was going to say to develop a one-size-fits-all solution. I understand that's not. Is the goal more so to give people tools to ask better questions?
Absolutely. So, in here we talk about there being 4 glass risk categories. And the architects and the building departments are used to this. They're used to a risk category 1 building. It's low occupancy, doesn't matter, it falls down. Risk category 2 is typical. It's anything that's not 1, 3, and 4. 3 is high occupancy. You don't want that thing to fall down because there's lots of people in there, and 4 is essential. Where in the glass risk categories, 1, it's like a glass house. There's nobody in there. If somebody throws a rock and it falls down, even the glass top, the odds of somebody being under it very small. Okay? And residential in some respects fits in that category, in that if somebody puts a baseball through the window, it doesn't matter. Okay? Glass 2 is that sort of typical, it's not in 1, 3, or 4. And for that, it makes sense that if the glass breaks and it falls out, as long as it doesn't fall somewhere where there's lots of people, and as long as it doesn't fall from a great height, it's probably okay. 3, you get into the situation where you get the building risk category is there a commercial implication, is there a societal implication, or is there a life safety risk associated with it? So this is where you say, I want the glass to stay in place long enough that I can do a make safe, or I can get a replacement piece of glass, without having to shut down the building. And so it's just kind of there as it doesn't fall out, but it's not necessarily 100% anymore. And then, category 4 is a bit like the glass floor and the Space Needle, or the barriers which are up there, which it says, if I break this panel, even if it gets broken for whatever reason, the glass barrier's there, if all plies break, it'll still stay up there. You're not dropping a 3,000-pound piece of glass 600 feet into the queuing area of the Seattle Space Needle. And so it's extremely robust. And so this idea, if you've got design strength and you've got robustness, those two things need to play off each other. With a piece of steel, they kind of go together. No matter, you add more capacity to the design thing, then it bends a little bit, and it's got an increased robustness and post-damage capacity. But a piece of glass, you take a monolithic piece of glass, particularly fully tempered or heat strengthened, and you get a chip on one edge, and the whole thing just falls into dice and falls apart. So making it thicker and heavier, doesn't matter whether you've got 8 in 1,000, 1 in 1,000, 1 in 10,000. It just gets thicker and heavier and more expensive, and when it falls, that heavier piece of glass is actually more dangerous.
I got to give credit to Russ Davies for this one. I asked, this was a couple years ago, I asked him on the podcast why he thinks glass is, the complexity of glass when it comes to behavior and limitations and so forth is so widely misunderstood or maybe underestimated. And the sort of common response was maybe the transparent nature of it makes people sort of underappreciate the complexity and beauty of what the actual material is doing as a system in its entirety.
The answer to this is brilliant, okay? And for the longest time, we've accepted that the price we pay for transparency is that if it gets whacked and it gets cracked, we replace it and it falls out. And we put a new piece of glass in. Well, that was fine when we were talking about pieces of glass this big, or even this big. But now you can buy a piece of glass that's 30 meters long, you know, and 12 foot wide, 60 foot tall, you know, huge pieces of glass. Obviously, if that breaks and starts falling down, it's a completely different story. And so you get to this point where it ceases to be, what was okay then is not necessarily okay now because the behavior of the way it acts afterwards. On the complexity side of things, the engineering is very different. Okay, typically we're dealing with products which are compression constrained. So they start yielding, they start buckling. Well, the buckling side of it is interesting because our glass is generally incredibly slender to the point where steel engineers and structural engineers are just like, you've got an L on R of what? You know, it's like, and then you're relying on the structural silicone, on the tension flange to restrain it. Yeah, I am. I've got a compression side with no flange on it that is 300 deep by 12 or 16, and it's like, the slenderness is crazy. You've got a tension controlled material, not a compression controlled material, and you've got slendernesses which are just nuts, and you've got lateral bracing from elastic elements such as structural silicone. And you just don't see that in any other materials, which means it's not what engineers are used to seeing from their training and their comparable materials that they were taught at university. So interestingly, one of the things that this does, we did a whole bunch of fundamental research for this, and we looked at what were in the existing standards, which ones matched up with testing, which ones didn't. You know, was it still applicable when we have laminated glass versus monolithic glass? And we find that the standards and the practices haven't kept up with the technology.
That's what I was going to ask. So with all these new technologies coming out, thin pieces of glass, packaging glass, electrochromic glass, all these different variants,
Yeah.
how much do either existing design manuals, existing codes, and guidelines apply there, and how sort of off base do you have to go, or project specific do you have to go if you want to use one of these newer technologies?
A lot of those things are in play. This is dealing with the structural aspect of it. So things which are dealing with the thermal, things which are dealing with VIGs, etc., they've got their own process of trying to play catch up, and we see that VIG, for example, the ISO codes are trying to do things, and it's not so much happening here in the US as it is on an international platform. So those things are happening, but if we're going to talk about structural glass, we've got traditional PVB interlayers, we've got ionoplast type interlayers, we've got the capacity to do really big laminates now. On one hand, we've got these things which are getting really big and that changes the way they behave. On the other hand, the capacity to control how it's actually failing makes a difference. So we don't have to accept that because it's transparent, we want to look out a window, that if it cracks, it falls down. We have the choice, and we have the technologies that allow us to control that process. And so when we're saying, a window is statistically acceptable, if it breaks under a wind load, doesn't matter. The consequences are really small. Take the Space Needle glass floor. You don't want to drop somebody 600 feet through a glass floor. It's not the type of publicity that they're looking for. So when we're doing that, you talk about a thing which you can take a sledgehammer to and you can break into many pieces and you can still jump up and down on. Don't do that, by the way. But after we did the visual mock-up for it, we said, well, that's the official testing done. What's the unofficial testing? And we took a sledgehammer to it, and we initially gave it to one of the architect consultants, and they said, no, it's crap. It's still good. Then we gave it to one of the subcontractors who was an Army drill sergeant. And he's just like, man versus glass. Yeah. The only way he got through the third layer is because he'd hit it 6 times in exactly the same spot and turned it to sand, and he was hitting the third layer. That sort of level of robustness, and we could still jump up and down to it with a group of 6 people on it. That sort of robustness in glass isn't what we think about as being glass, but it totally demonstrates the capacity for this material to be used in a robust structural manner with incredible residual capacity. It means that you can safely build these structures. Now, one of the things that we're trying to do here is say, okay, we've got the technology, we've got the capacity. When is it appropriate to use it? Because the technology costs money. Okay, so you've got the laminated glass. And that example before, you've got a glass bin in a retail situation at ground level. If it falls down, it's probably no big into the display case, and it's only falling so far. But you put exactly the same thing in a stadium venue. Okay, and it's this glass wall, it's 50, 60 feet tall, and you've got 1,000 people going out the door all at once. A piece of glass breaks at that point and it falls down. The consequences are completely different. And so when we're talking about glass design, we're talking about vulnerability and robustness as well as design loads. So ASC 76, which is prevention of disproportionate collapse of buildings and like structures, has this great formula. And it says, risk is not the probability of occurrence, which is what we typically think of all other materials because the other things don't come into play. It's the probability of occurrence multiplied by the vulnerability multiplied by the consequence. So if we start thinking about glass, and the fact that it's vulnerable to non-design events, it's not usually the heavy wind load or the live load that breaks it. It's the guy with a leaf blower or a whippersnapper that throws a rock and puts a crack in the system, or glass floor and they drop cutlery. You know, these things are the events which are way below design load. But if you've got a monolithic piece of glass, the crack still goes full depth no matter how thick you make it, right? And so this, by having these 4 categories, it's like, this can be cost effective, this can be as robust as you want. And it's kind of a graduation in between, and I think that's the part which makes glass so complex, is it's okay some of the time and it's not the other. So how do you make a rule for that? And the answer is one size doesn't fit all, right? You know, you've got to actually subdivide and say, this is cool here, this is amazingly cool here. I can do heroic things and I can do cheap things and I can do safe things. And if you can get that spectrum, then you're enabling glass design for the whole industry. And you're making it accessible to architects who aren't experts, and you're making it accessible to engineers who aren't experts, and you've got a level of understanding for owners that are like, I'm afraid of this, but this is cool. And how do I do it? Oh, I've got a roadmap. There you go. Yep. And so if we can give people a roadmap where they can say, this is what makes sense, and instinctively it makes sense. I've got people that talk in the building department saying, thank goodness, because they inherently know that glass is dangerous. They don't know what to do about it, and they're just saying, test it to this incredibly high load. It's not the word I was going to use initially, but I stopped myself. And then it doesn't actually prove the safety of the system. All it does is prove that it has a high design capacity, but that's not what breaks glass. So it makes it a kind of pointless test that all it does is add cost.
Yeah. So structural glass design manual, how to make glass more accessible to the wider audience. Richard, thank you for coming on.
It's been a pleasure. Cheers.
Thank you. All right, so I got my introduction to Rayco. First, before we dive into all the system intricacies and so forth, feel free to introduce yourself to the audience and where you focus on the Pacific Northwest.
Yes, we do. We represent Rayco, and we are a glazing contractor based in British Columbia, and we do jobs all over North America, but mainly the Pacific Northwest is our focus. And typically high performance, so passive house and the like, or specific materiality like timber back sections, steel back sections, freeform skylights, and types of applications where air and water and shapes become challenging. And so this is what we're focusing on with our fabrication company, Blackcomb Facade Technology.
So the super interesting part is I have a background with Schuko systems and understanding the means and methodology of fabricating and assembling European-style fenestration systems. and it's obviously very different than what we see here domestically or in the USA, or sort of the way these systems have evolved over time. Before we get into that, like sort of third tier of fabrication that you were describing, what do you think was the original evolution of why the way European and domestic or North American systems sort of went two different directions or paths in the way they thought about means of, as you said, drainage, air tightness, gasket joinery, how you manage air, water, thermal continuity, and so forth?
I think a lot of it has to do with the way Northern Europe thinks about the environment, and you know, these companies are as old or older than most of the North American big system houses. But that being said, like the Passive House Institute started, I think, in the 80s or 90s, and then in Germany. And so that type of influence in terms of air and water management, thermal performance, made them evolve. And so because they cared about the environment, because energy in Europe is really expensive, because they wanted to reduce their footprint, they went to this application which mitigates the impact or demand on energy for single family homes and commercial buildings. So they've been thinking in such ways for much longer than North America. And in our experience, we've been working with European systems for 10 years, mostly driven by, we sought them out for reasons of quality first. There's also a culture where they care a little bit more about the finishes and about everything that has to do with just handling of material. Like we would get scratched up and dinged material from North America, and from Europe, it comes half a world away, and everything's in sleeves and well protected, and everything's perfect the first time. So there's that the start. But second, the building codes in BC evolved really quickly over the last 10 years, and still evolving. But by 2032, all buildings in BC, in terms of compliance with energy performance, will have to be, it's not necessarily a passive house building, but it's a passive house like building. So thermal performance and air tightness will be at that level. Let's use passive house as a reference, because it's, for all intents and purposes, it's a good recipe book to build an efficient building, if you will, right?
So last month we had Boston, and it's a similar model in that with the new Massachusetts stretch code, they're building, as you said, to the passive house standard level. So are you finding more and more teams opt to go with passive house compliance because they're already at that baseline?
Essentially, so for us, the demand, at least from our local market in British Columbia, it is sort of mandated, and we've developed this niche. Especially, it started more in residential, and now it's creeping into the commercial. Like the city of Vancouver itself has mandated that all of their buildings that they own, like fire halls and community centers and the like, would be passive house certified. So now we're on building 4 or 5 of those typologies. We're not creating this demand, it's the other way around. So we've developed this expertise, and the phone rings because of that expertise. And so, but it's very rarely a choice, an environmentally driven choice to build a passive house. There's some, homeowners that would make that choice, but that's not what we're seeing. We're seeing this as code driven, very code driven, or mandated by a government body like the city of Vancouver.
When you're working in a market, part of the discussion earlier in the podcast was people electing to build to baseline code and not electing to go above and beyond unless there's some other extremity or driving factor. And so British Columbia is an extremity, at least in North America, in terms of this standard. So when some of the projects you were showing me where you're building to incredible sizes or spans and spanning multi-story and with units under load, how are you mitigating or combating all of that gasket joinery we were talking about to still achieve the air tightness requirements? All of a sudden, are the units under much more pressure, and are all those interface conditions stressed that much more?
No, not necessarily. The biggest challenge for these really big spans and with high loads, especially when we're talking about Rayco's steel system, which can take much bigger loads for glass weight and for wind load, for deflection. It's when we bring in the seismic racking consideration, and that code has evolved over the last maybe 2-3 years, where it's the amount of movement within the stick build system is quite high. So that's another new challenge that we face, that we figure out. But it's job by job. we've got to adapt a little bit. So that's been the challenge. But the joinery and the gaskets, the Rayco system is pretty bomb-proof the way it's applied. The gasket's really robust, and instead of being spline gasket, I mean, I'll urge your listeners to go and look at Rayco and their catalog, but it's essentially this continuous gasket over the whole plane of the glazing pocket that when it's locked in with pressure, it's bomb-proof. So.
And how is it connected at the corners?
It's dry glazed in the vertical plane, and then in a skylight application, it does receive some injection of sealant, but only in the glazing pocket, not behind the gasket into the warm space or the back section. Yeah.
So for me, for a very long time, it was sort of unconventional to do designs like this in a dry glazed application.
Mm-hmm.
All I really knew was wet sealing,
Mm-hmm.
Especially coming from the unitized curtain wall side of things. If that's all you've known, or if that's what you're accustomed to, do you look at me as if I'm crazy for even asking that question?
No, not at all. Because the first time I saw, like 10 years ago, the first time I saw the Rayco system, I thought there was something wrong with it, not the other way around. And you know, on our team, we have some older glazers and everybody's reaction like, what is this? And how does it? It's so strange. But then once you start looking under the hood and getting a bit of more traction and experience with it, then you can see like how powerful it is in terms of it taking the architectural intent, whatever that is, and adapting it and not having to design a bespoke application that requires a ton of SSG applied in the field. So yeah, it's hard to say in words, but that's it in a nutshell. Yeah.
How have project teams, in terms of facade consultants and designers, received it? And if it is sort of a system fabrication methodology they're not comfortable with, are a lot of performance mock-ups required? Do you have to sort of prove compliance through testing in the fabrication shop?
So Rayco's systems are ASTM tested, so that's the certificates are there to prove out the system. I would say that most envelope consultants that we know are well attuned, and so the North American consultants, I'll rattle off a few, like Stantec, Morrison Hirschfield, and RDH, and Richard Green, who's here promoting his new book. Like they all received this with open arms when we presented our wares to them, because they right away they saw this gap in the products of limitations. They've seen enough PMU tests fail.
They like the idea of triple weather stripping.
They do, and as opposed to compartmentalizing the glass, that the continuous gutter drainage, which is essentially, it's a skylight system that we're putting in a vertical facade. So the water shedding piece is pretty strong, and everything being positively lapped, it's once you see it go up, you realize, oh yeah, that makes so much sense.
In your eyes, is this a very performance-driven product?
Totally, and it's different strokes for different folks. In terms of price, like the aluminum sticks they're very similar in price than what we can get in North America. So it's not like it's pushing those boundaries. Where we're getting a bit more resistance on the price side is the doors and operable vents. You look at what they are compared to a commercial door, North American door, they're not the same. And so that you can see that there's value in why it's double, sometimes triple the price. But that's a discussion for another day. Like if the nuts and bolts of this is the curtain wall and skylights and the interesting things we can do with the different materiality, right? So
on a finishing note, what's your favorite project, or a project that you think is the best demonstration for people to look up or look at to get a sense of capabilities?
One that we did recently is the University of British Columbia, the Museum of Anthropology. It was an Arthur Erickson building built in the 70s and needed a reno. The acrylic skylights, curved acrylic skylights, there's about 12,000 square feet of them, needed to be replaced. And so we replaced them with Rayco's steel system. The project worked beautifully, and the scrutiny with the testing, PMUs, the seismic racking we did on the PMUs, the site testing, there was 4 B7 tests done on site on these skylights, all passed. And so aesthetically, performance-wise, it's a really beautiful building. And then the other building that I would say is a crazy reference is called, I'll pronounce it in French, it's called La Scène Musicale. So it's a music venue in Paris across from the Eiffel Tower. It's a ball shape. So it's a mass timber grid shell with the Rayco system applied to that mass timber grid shell, and it's huge. And it's absolutely beautiful. And then the probably the epitome of like an integrated design, directly applying the glazing system to the primary structure and using the least amount of components to achieve this facade, right? So direct to the structure is the lowest footprint in terms of us as glazers not adding more than we need to a job. So
Yeah, absolutely. We'll be sure to share those projects here and put them up on the screen. And thanks, JF, for coming on.
yeah, thank you. Pleasure.
So we got our third repeat guest of the day, Doug, back with Clark Pacific,
Yeah.
and we got the newest Seattle member. So introduce yourself to the audience.
I'm Tony Pydych, and I'm Senior Director of Business Development for Clark Pacific, actually Manager of Business Development, and working up here in the Pacific Northwest. And we're growing into the Northwest market here, and I've got my entire career up here in Northwest. So I'm working with Doug, and we're going to go out and spread the word about Clark Pacific, and that's what we're here for today.
Yeah, and to reintroduce myself, my name is Doug Bevier. I'm Director of Development here at Clark Pacific. We do a lot of products from structures to high-end facades and everything in between. I oversee our business development, sales and estimating departments for Clark Pacific. One of my main focuses right now is, helping with our engagement into the Pacific Northwest market and educating the folks up here what we can do and what value we can provide for the buildings.
So that's Clark Pacific, for context, is one of the biggest, call it, prefabricators in the country. Most people know them West Coast predominantly being California based. So what was really the big move, and I'll say from your standpoint, to go north instead of going south?
Yeah, certainly. We started in 1963 prefabricating facade systems. That was kind of our bread and butter, and that's what we're still most known for, high-end architectural. GFRC, we helped develop the industry there, and kind of a few different hybrid products all in between. When we were talking about precast and prefabrication in general, back in the 60s and 70s, the main thought was you had to have large urban cities to get the value out of prefab. A lot of thought you had to have large scale buildings where offsite manufacturing made a lot of sense, where you had on-site labor concerns, or you had logistical errors or issues that made prefab, well suited for it. What we've seen over the last, I would say, 5 years is that a lot more prefab has been pushed to more urban environments and more building systems. So not just high-rise buildings that have site constraints, but the value of having two different job sites where you can accelerate your schedules and offer more value to the end user. I mean, that's transcendent from a job site in middle of nowhere Utah to Boise to the big cities like San Francisco, LA, San Diego, which were our core markets. And then in addition, I'll add, and Tony can kind of highlight why the Pacific Northwest, but precast are very high performing facade systems and structures. Typically when you are in environments that either have standards that require higher performing facades or weather constraints or environments like the Pacific Northwest, our systems are going to add more value to the end user. You can't, if I'm talking about the Southwest market, your Phoenixes and San Diego, where you have much more temperate climates or drier weather, where you're not as concerned with water intrusions and things of that nature, or weather delays out on the job site, or you can use a lower performing, I'll just say it, EFIS system because you have less risk as an owner.
So coming up to the Pacific Northwest, selling the concept of prefabricated, it's not a constraint or challenge per se. Is it more around market education?
Yes and no. I mean, the designers that work up here in this market are very sophisticated. In fact, the Pacific Northwest has some of the top architecture firms and engineering firms in the country. It's also got very savvy client base, developer clients that understand the value of pre-construction in the building process. They're cost driven, they're schedule driven. We've got some of the titans of the industry up here on the tech side. Obviously, the companies like Microsoft and Amazon that are headquartered here and started here and emanated out of the Pacific Northwest has created, very strong market, well-educated market, savvy market for building. So the idea of prefabrication and modular construction, has existed for a long time. They're aware of that. And I feel like Clark Pacific is perfectly situated right now to come into this market, which has lost a few partners, lost a few precast concrete, suppliers in this market over the last 10 or 15 years. So it's a great opportunity. And, a lot of the projects that we're seeing too in other regions are springing out of the design and engineering and owner teams that are right here in Seattle.
Yeah, that's what I was going to add. There's a lot of designers here in town that, like Perkins and Will is a great example. They're designing buildings in California. We've worked with the Seattle office and on buildings in I would say our core regions for many years. And so the education and the sophistication is there. It's just more about getting the word out about these product offerings are here. And Tony mentioned as well, this Seattle and Vancouver were actually very robust precast markets back in the 80s and 90s. I'm not sure why they stopped and kind of transitioned to a lot of the glass kind of curtain wall systems that we've seen throughout the last years. I think it was some manufacturers and some providers that had very cost driven products that kind of expanded their market reach. And then in addition, I think there was less precast available. And so
That's what I was going to say. Was there a limitation or a limit in the number of architectural precasters serving the market, and any reason why other precasters weren't targeting this area?
I mean, I think the Seattle market, Seattle Bellevue market, and the Pacific Northwest in general, it's a provincial environment. So there's a lot of, locally owned companies that are producing products like on the construction industry side. I was involved in a pretty significant precast concrete project at Bravern in Bellevue. That was with Skanska and Cowles Architecture and MBJ Architects. Shout out to those guys, by the way. That was all precast. And, we worked with a local precaster on that who no longer is in business. So they've just gone away for various reasons. Some of it might just be generational. It could have been the pandemic, and some of the downturn might have affected the economics of it. The other thing I would add is the sort of how our weather up here drives some decisions on how to facade a building. EFIS has not performed well up in the Northwest due to the marine climate and some of the issues associated with just how EFIS has performed. And some of that is related to the product, some of it's related to the installation. But that sort of influenced, I think, the rise of curtain wall systems up in this area, the high-rise market. So I feel like now with the energy code sort of evolving the way it is, people are wanting to take a stronger look at our products, our prefabricated precast, high-performance facade products, because of their resilience and their energy code performance now with the changing energy code and thermal bridging and things of that nature. It's a durable, resilient product. It's got a long warranty period. It's low maintenance. So building owners over time are finding out now the cost of maintaining these buildings is significant over time as you try to just maintain the skin of the building, wash it, clean it, the sealants. So there's a lot of really great reasons why our precast facades make a lot of sense. And just working with the designers up here and talking to them today at this event, a lot of folks that are attending this event are really interested in our product now. They see the value, they see the schedule acceleration benefits, the multi-trade approach that we have, just our erection sequencing, all the stuff that we provide as our product lines is true value to the projects.
And do you deal with similar seismic constraints up here?
Yeah,
absolutely.
Yeah, and so we have a very resilient system. There are some seismic areas that are similar to that of California. So, we've driven, our product development around how we handle those movements. We say precast and GFRC a lot. We are a full facade provider, so we love to include anything that we can add value to the client. So we're going to have our glazing systems installed, louvers, anything that we can put in at the plant, we're going to do. So one of the other benefits that we'll see, especially in like the Seattle area, is that we'll have 6 or 8 guys on the job site, and that'll be that's it. And they're going to put up the full facade. And then historically, you talked about the Bravern, but the precast that was up here was traditional precast. So for those of you guys who may not know, it's 4 to 6 inches thick. You can really robust product. You can do a lot with it. But it is a heavier product. And so in California, due to the seismic concerns, when you get to high-rise buildings, there's all this discussion about, hey, how do we lower the building weight so we don't have to spend as much money on, lower the base shear, spend less money in the lateral systems, albeit facades are such a small portion of the actual building, it's not going to have a tremendous effect. That said, we started developing lighter weight products. That's why we went to our GFRC or our Infinite Facade, which is a 2.5-inch concrete skin, similar technology as GFRC. That hasn't been used up here. And so that is something that we are educating the local designers of different options that we have. We recently, just this week, set our last piece in Olympia on a project called Pritchard. That was GFRC. That would be our first GFRC product that we delivered to the Pacific Northwest region. So we're really excited about that.
So what would be, on a final note, one project if you wanted somebody to see a CCAP or Infinite Facade example of that lightweight system, maybe in the San Francisco area as a precedent? What would be your favorite project to show?
My favorite project to show is a campus we built called Mission Rock. You can look it up online or on our website at clarkpacific.com. The reason I love it, it's 3 buildings and it's all 3 of our products. So Mission Rock G, which Devil's Tower in Wyoming, that's what the inspiration for the building was. It's 70% glass, but it was still traditional precast. So it's very impressive how we were still able to panelize it, install the windows ourselves, and put it up. Then we had the Mission Rock A, which is the canyon. The inspiration was the Grand Canyon. It's a red GFRC lightweight product, very complex ins and outs that also had pre-installed windows, metal panels. We did some door scope on that project. And then the last one, which is my favorite, which is a studio gang project, Mission Rock F. The inspiration was Yosemite, the falls out there. It's our infinite facade with the 2.5-inch concrete skin, and we embedded glazed green brick. It's very, very unique. The building kind of twists, but if you go look at the Mission Rock website or ours, you're going to see kind of the versatility of all the products. And I just want to hit one more note about insulated wall panels, and that's kind of our other facade system, and really was another inspiration of coming up to the Pacific Northwest due to the mission critical work, a lot of the data center work. So we'll do insulated walls, which is typically a width of concrete. Then you have a layer of rigid insulation, and then an exterior width of concrete. That'll have, you can do your architectural finishes and features like that. Very kind of common around the US. But I think, so we were intending to come to the Pacific Northwest really to attack the data center market and mission critical. And then we saw this other opportunity with our facade systems, which is really where we're having a lot of traction and building a lot of pipeline. But when everybody's talking about insulated walls, I always want to highlight reaching out to your local manufacturers, whether that's us or somebody else early on to get the most value. A lot of times they'll have a steel building and want us to put just a simple facade system that hangs onto the steel. Nothing's wrong with that. But our products are so robust that they can also take structural loading. And so, yeah, we are the facade system, continuous insulation, high performing facades. But if we add an extra inch to the back white, or maybe 2 inches, we can be your lateral system. You can weld your framing members directly to the back of the panels. And so what you're eliminating for the client is all your exterior framing, all your exterior columns, and your lateral brace frames. And so you start thinking of, we can actually take structure, funds or budget from the structure and putting it into the facade for a very small premium, and then you're either getting more value to the client, or you can maybe add more premiums, more finishes and things of that nature. And so anytime you're thinking about prefabrication, it's reach out to your local manufacturer to understand capabilities and total value.
Well, we have a lot to take away from this one. So guys, check out the Mission Rock development if you're looking for opportunities in the Seattle area.